In this demonstration, we're going to be focusing on the first stage of any modelling for manufacture demonstration, and this typically involves the alignment of the part to remove any undercut regions and checking the integrity of the data. So we're going to be looking for such things as duplicate surfaces, badly trimmed surfaces, overlapping surfaces and gaps between surfaces. And then finally we're going to be adding additional surfaces to the part to aid in the manufacture of the component. The part in question is a metal pressed part and is a boot frame component from a car. So to begin with, we're going to select all the surfaces, and then we're going to run the Find Duplicates option. And as we can see, the information dialog informs us that there are 3 duplicate surfaces which are highlighted. If I just blank the rest of the part, you can see the 3 surfaces on the screen. We can simply delete those surfaces as they are no longer required. Let's bring back the rest of the part with Ctrl L. And now we're going to move on to identifying any badly trimmed surfaces. Now in this case, the information dialog informs me that there are no badly trimmed surfaces and everything is correct. Okay, so now we can start to look at the alignment of the part, bringing the part into the correct line of draw for machining. To do this, we can use a simple visual aid, which is the Undercut Shading, and this will shade the part in 3 colours. Green being areas of surface that are well above, areas of the part that are well above our draft angle. Yellow being areas of the part that are close to our draft angle but still above our draft angle, and red are areas of the part that are below our specified draft angle. So if we select one of these surfaces and switch on our surface inspection mode, we can interrogate the draft angle at this position. So here we can clearly see there's a negative draft angle of 4 degrees. So this will have to be rectified before we continue. So we're going to switch off our undercut shading. To align the part, we're going to use a simple work plane rather than rotate the geometry directly. So we're going to switch on our work plane toolbar, and first of all we're going to create a work plane that's aligned to the geometry. So this will simply align the z-axis normal to the surface underneath the cursor. Now by using the dynamic dragging, we're going to pick up our work plane and snap it to this corner position here, and using the grab handles we're going to pick up the y-axis and spin it round so it's on the perpendicular edge here. And then finally we're going to double click on our work plane and we're going to twist the x-axis of our work plane around the x-axis by -3 degrees. Okay. So now we've created a new alignment. Let's just go back to our undercut shading. And here you can see that all those red areas of negative draft have now been removed. And if we just spin round the part looking at various areas, we can see that nearly all the part is now in the correct alignment, except for a small region here where we can still see a region of red undercut area. So this region is going to be fixed by modifying the draft angle in this area. We'll switch off our undercut shading again. And we're going to select the fillet at the bottom of this pocket. We're now going to create a new draft curve on this fillet with an angle of 2 degrees, like such. And there we can see, if we zoom in and select the curve, the new draft curve. We're going to use that draft curve now to trim back our fillet using the limit selection option. I'll just zoom in, pick the fillet, and then that will be trimmed back to that region. Next, we're going to create a new draft surface to replace the original surface. So we can delete this surface and start to create our new draft surface. So we're going to look along the x-axis at the end of the part. I'm going to create a new work plane. And I'm just going to pick up on a key point in this region and just position a work plane slightly above the top of the part. Next, we're going to create a draft surface from our composite curve. Create a surface, a draft surface. Now it's going to be tangent to the underlying surface, so you can set the draft angle to 0 in this case. And we're going to project onto the principal plane, which is the work plane we created earlier. So if we preview that, we can see the new draft surface. At the moment, that draft surface is too long and needs to be trimmed back. Now, because we've created a new draft surface with a 2-degree angle, the position of this fillet is now wrong. So this can be deleted. And we can go in and create a new fillet between the surfaces. So we're going to select the surrounding surfaces. Like so. And then go into our filleting surface option. And then select the other surfaces to fillet onto. So we're going to put a 4.5mm fillet, convex. We're going to preview that. That looks okay. And then apply. So there we have our new fillet and our new draft surface. So we're just going to select one of the surrounding surfaces and paste the attributes of that surface to our new surfaces. If we now delete our original work plane, that's no longer required. And we can double check to make sure that has fixed the undercut in that region by going back to our undercut shading. Make sure we have the work plane active that we created to align the part. And there we can see that red region has now disappeared. At this stage, we can also check for any minimum radiuses required on the part. So we can switch on our minimum radius shading. And here we can see any radiuses that are below our minimum radius setting will be shaded in red. The red shaded fillets indicate any concave radiuses that are below our minimum radius setting, and the green convex shaded fillets are any convex fillets that are below our minimum radius setting. So the minimum radius setting we want for this part is 3.5mm. So if we go to Tools, Options, and set our minimum radius shading to 3.5. Here we can see that this fillet is still shaded green, meaning it is below the 3.5 millimeters. If we double check that with our surface inspection, we can see that the actual radius is roughly 3 millimeters. So now we can go in and delete this 2 fillets and then do a new surface fillet between this top surface and these bottom surfaces. So our new fillet is going to be minimum 3.5, and it's going to be a convex fillet. If we OK that and apply, the new fillet is now in place. So I'm just going to copy and paste attributes of the surrounding surfaces again. Next, we're going to move on to creating additional surfaces to aid in the manufacture of the part. Typically, we're going to be filling in holes in the part that are not required when it comes to machining the dies, and filling the holes will prevent any cutting tools from going down below the surface. So you can see we have several features that have holes in, and to fill those holes we're simply going to go into the trim region editing for each surface and select the hole boundary and remove that. Do the same for the other surfaces, quickly and simply just selecting the boundary of the hole and removing that boundary. Many times a part may contain small gaps or overlaps between surfaces that are very difficult to spot just by visually interrogating the part. In this instance, it's a good idea to turn the component into a solid model and use the solid doctor to identify and fix these errors. So we're going to select all the surfaces and convert it into a solid model. And now we get a message asking us if we want to fix the faults in the solid. So we're going to say yes to this and jump straight into the solid doctor. The solid doctor will now analyze the solid model and list any faults that exist. So we're going to run through these faults one by one. So we're going to zoom in on the first fault. And here we have a gap or an overlap between two adjacent surfaces. So we're going to try an automatic repair first of all to see if that solves the problem. In this case it hasn't solved the problem, so now we can go in and choose one of the alternative methods for fixing the gap. In this case we're going to extract the surfaces around that gap and edit them manually. The first thing we're going to do is select this surface and blank the remaining surfaces, and we're going to create a composite curve from this edge, from that key point to the key point at this end, like so. We're just going to extend that slightly. Simply pick up the end and drag it. Likewise for the opposite end. Now we're going to bring back the other surfaces, blank off this surface, and use a composite curve that we created as a limiting tool to limit the other two surfaces. So we limit the first surface back, and the second surface is okay. So we're going to bring back the surface we blanked earlier, delete the composite curve, select all the surfaces that we brought through for editing, and then accept the changes and go back to the solid doctor. So you can see that that identification has now turned green, indicating the fault has been repaired. So we're now going to move on to the next gap. In this gap again we're going to use the extract the surfaces to manually fix the gap. And we're going to select this surface, select the point, we're going to just insert an extra lateral into the surface, and then pick the end lateral again and stitch to this curve with a 1mm maximum gap, and that will edit the end curve to match the adjacent surface and also match the tangency across and along the edge. So now we need to reselect all the surfaces and put them back into the solid. And there we see the fault has been repaired. So we'll move on to the final of the small gaps. In this region here. Once again, we're going to extract those surfaces for manual editing. And we're going to delete this surface as we're going to create a brand new surface in this region. We're going to select this surface and this edge, and holding down the control key we're going to drag in a new lateral. Select that lateral and break the surface at that position, and delete the surface this side of the new lateral. And then we're going to fit a brand new surface to fill in the gap. So we're going to use our automatic surfacing option and create a composite curve. Just to go round the outer profile of the gap. And then that surface is filled in. And we're just going to change that from a network surface to a fill-in surface to give us a smoother surface, and OK that. We can delete the composite curve now as we've finished creating the surface, and as before select all the surfaces to put them back into the solid. So there we have another gap that's fixed. So if you go back to our solid doctor, you can see that now all the small gaps have been fixed, and we just have large gaps remaining. So we're going to go through those one by one. Okay, this is an intentional hole that needs to be filled in for manufacture. So we're going to create a fill-in surface with a tangential surface. to remove that hole. Then we're going to move on to the next. Okay, here we have a missing surface and a badly trimmed fillet. So this, first of all, this fillet needs to be trimmed back correctly, and then a patch surface put in to fill the hole. So this will have to be done manually. So we're going to extract the surfaces around the hole and edit them. The first thing we're going to do is break this surface here and delete this section, and do the same with this surface and delete this section. Then we're going to create a composite curve from this edge just by converting the edge to wireframe. Like so. And then we're going to take the two pieces of wireframe and we're going to append them together to give us a smooth blend between the two. And this is now going to be used to limit our fillet. So go to our limit option, and we're going to use project in Z mode, and we're going to lock our limiting object, which is our piece of wireframe, and then we're going to trim back the three separate fillet sections to our composite curve. We can delete that composite curve, it's no longer required. And now all that's left to do is go to our automatic surfacing again and sketch a composite curve around our remaining hole and create a fill-in surface in that region. So select all the surfaces and sew them back into our solid. There we have another fault fixed. So slowly, one by one, we're going through all these faults and filling them in. Here is just a simple case similar to the one we had previously, but here we don't have to do any trimming of the surrounding surfaces, so we can go straight in and fill with a tangential surface. This example is slightly different. Instead of it being a hole, it's actually an overlapping surface. This planar surface at the top here has not been trimmed back correctly to this fillet surface and is overhanging. So to fix this, we need to manually select the surfaces and edit and fix it manually. So to do that, we're first of all going to create a composite curve, blank off the rest from this edge. So from this key point to this key point, bring back our other surface, select our composite curve, and as before, simply use limit selection to trim it back our planar surface. Delete the composite curve, select all our surfaces and put them back into our solid. Okay, moving on to the last of our large holes. Again, this is an intentional hole in the part, but still needs to be filled in for manufacture. But this time it's a planar surface, so we can simply remove the boundary of the surrounding surface, like so. All that's left now is one remaining small gap, in this region here. So here we have a slight gap between two adjacent surfaces. We can try an automatic repair here. In this case that didn't work, so we're going to manually fix that gap by extracting the surfaces. And to do that we're going to just simply select one edge of the surface, hold down Control and drag in a couple of intermediate surfaces in this region, like so, in the region where the gap is, and then we're going to stitch that surface to the adjacent surfaces, like so, and then select all the surfaces involved and go back into the solid doctor. And there we can see that gap is now fixed. So if we go back to our solid doctor and look at the Explorer tree, we can see that all the faults have now been fixed, and we can simply finish and exit out of the solid doctor. The final thing left to do is to simply mirror the part about the YZ plane, as this is only half of the intended finished component. So we're going to mirror with a copy about the YZ. And there we have our finished boot frame component with all the faults fixed and in the correct alignment for manufacture.